Welcome back. In this video, we learn an example for k-means clustering. First, we'll have a revisit of k-means algorithm. The input for the k-means algorithm is k, where k is the number of clusters, and then d is a list of data points. The first step is initialization. Here we need to initialize the number of clusters, k number of clusters. The second step is the assignment step. Here each data point will be assigned to its nearest centroid. The third step is update step. So if needed, we will be recalculating the centroid for each cluster by averaging the data points. And then if needed, we will be repeating the steps again and again until there is no change in the cluster center. This is k-means algorithm. Now we will be solving a problem using the data set. This is the given data set x and y. Here there are two features, x feature and the y feature. So for example, I have shown you how the points are plotted in a graph. So 2, 4. 2, 4 is plotted here. The next data point is 2, 6. 2, 6 is plotted here. So that way all other data points are plotted in a graph. Now we are going to group these into clusters. So the first step is we need to select number of clusters. Here the number of clusters selected are 3. So in the first step, what we will be doing is we need to find the seed point or the center point for each cluster based on the given data points. Now in this example, I have chosen some random seed points 1, 5, 4, 1 and 8, 4 as the cluster centers for 3 clusters. Here we will be using the Euclidean distance, and this is the formula for two features. Here we have two features, x and y. So it is given us for two features and for two objects. We will be comparing two objects and then we will be finding the distance between the center point and one object, then the center point and the next object. So that way we will be finding the distance. Okay, so this is the distance formula, root of x2 minus y1 the whole square plus y2 minus y1 the whole square. So these are the three seed points for cluster 1, cluster 2, cluster 3. And these are the data points, x and y. X and y are the features and these are the data points. Now for the first data point 2, 4, we need to find the distance to the first cluster. This is the first cluster, this is the distance to the second cluster, and this is the distance to the third cluster. So we need to find the distance between 2, 4 to the first cluster center 1, 5 and to the second cluster center 4, 1 and to the third cluster center 8, 4. Then after finding these 3 points, we need to find which is having the least value. Based on the least value, we will be writing the cluster number here. Now we need to find the distance. So how to find the distance? The data point is 2, 4 and the seed point is 1, 5. So we select the seed point as x1, y1 and the data point as x2, y2. The distance is measured as Euclidean distance. We have seen this formula. Now we apply the data points to this formula. So we will get a root of 2 minus 1 the whole square plus 4 minus 5 the whole square. We will get root 2, which is approximately 1.4. So we fill it in the table. Here we fill it out. Similarly, if we find the distance from the data point to the second cluster, okay, as well as to the third cluster. So when we find out, we'll have 3.61 as well as 6. These are the cluster distance between the data points and to its cluster centers. Now we need to check which cluster is having the minimum distance to the data point. So cluster 1 takes the minimum distance. So this data point 2, 4 is associated with cluster 1. Similarly, we need to find for all other data points, and I fill up the table. This is the final table. Now, when you consider here, the first data point belongs to C1, the second belongs to C1, the third belongs to C3 cluster, fourth belongs to C1, and so on. Certain data points are clustered to one cluster and other data points are clustered to second cluster and third cluster. Now, the next step is we need to find the cluster center. We need to rearrange the cluster center again. So, how to rearrange the cluster center? We have 3 data points in cluster 1. The first one, second one, as well as the third one. These 3 data points we have in cluster 1. So, we are selecting these 3 data points. Now, we need to find the average of these data points. That is said to be k-means. Means in the sense, we will take a mean of it. So, for k number of cluster, we will be find based on the mean value or average value. Again, we will be fine-tuning the cluster center. So, here we are going to fine-tune the cluster center based on the average value. So, we will select 2 plus 2 plus 4. In X position, we have 2, 2 and 4. So, we select 2 plus 2 plus 4 divided by 3. Y3, we have 3 data points. Divided by 3 is equal to 2.66. And the next one is 4. Y is 4, 6 and 7. So, we take the average of it. 4 plus 6 plus 7 divided by 3, which we will get as 5.66. Now, this becomes the centroid for the first cluster. So, this is the centroid for the first cluster. Similarly, we need to find the centroid for the second cluster and the centroid for the third cluster. We have found out the centroid for the second cluster as well as the centroid for the third cluster. Now, based on these new centroids, we need to find the distance measure between the data points and the center points. We need to again do this iteration. Now, we move to iteration 2. The new centroid are, for the first cluster, the new centroid is 2.66, 5.66. And for the second cluster, the new centroid is 4.5, 3. And for the third cluster, the new centroid is 6, 5. Now, these are all new center points. For these new center points, we need to find the distance again using the Euclidean distance. So, here I have written the values. Okay. Now, there is a change. We need to check whether there is any change in the cluster values. So, previously 2, 4 was with C1, 2, 6 was with C1 and 5, 7 was with C3 and so on. When you consider this 6, 3, this was earlier with C3 and now it has changed its cluster center to C2. So, why? Because initially it was some other value here 2.24, which is nearby to which is less for cluster 3, and so it was with cluster 3. Now the minimum value is with cluster 2. That's why it's moved to cluster 2. This data point has moved from cluster 3 to cluster 2. So there is a change in the cluster data points. Okay, so we need to recalculate the centers. So centroid points. So how to recalculate the centroid points? Again, for C2 and C3 alone, we will be recalculating it, because for C1 already the first data point, second data point and fourth data point already it was with C1, and in this iteration also it is with C1. So no change, only the change is with C2 and C3. So we need to recalculate the cluster center for C2 and C3. Now we are getting these three cluster centers. Okay, based on these cluster centers, we need to proceed with next iteration. So our next iteration will be the third iteration. In this iteration, what happens is, for cluster 1, the centroid value have not changed at all. So it means that the value will be the same as such. No need to recalculate again. This column, no need to recalculate again. We need to recalculate for the second cluster as well as the third cluster. Why? Because these two center points have been changed in the previous iteration. So we need to find out for these two columns alone, and then we need to compare which is the best, and we need to find out the cluster number. So what happens here? Here again we have found out the values, and then we need to we will be writing the cluster numbers here. When we write the cluster number, initially this data point was with C3 and now it is with C2. So there is a change from C3 to C2. So again there will be again we need to compute the centroids for C2 cluster 2 as well as cluster 3. Why? Because there is a data point which has moved from C3 to C2. Okay, so there will be a change in the average value. So we will be recalculating these two things and we get new center points. These are the new centroid points or cluster centers. Okay, so now again we need to move to the next iteration. In the next iteration, what happens? This will be the same. The first cluster will be the same because there is no change with the first cluster. Only change have been done in second cluster and the third cluster. So we need to recalculate the distance measure between the data points and the cluster 2 center and to the cluster 3 centers. Then we need to find the then we need to find which is having the minimum distance, which cluster is having the minimum distance to the data point. Okay, so with this we'll be proceeding. So first cluster, the value remains changed. Second cluster and the third cluster alone we need to find out, and then we need to find out for a particular data point which center point is nearby. Okay, and then we'll be filling this out again. So now we get this new values. Here again, initially this data point is with C1. Now it has changed from C1 to C3. So there is a change from C1 to C3. So in this case, what we have to do? We need to recalculate the centroid point for C1 as well as the centroid point for C3. And centroid point for C2 remain the same. So we will be calculating. After calculating, we get the center point for C1 as 2, 5 and the centroid point for the cluster 3 as 5, 6.5, and the centroid for cluster 2 remains the same. So no need to change the middle column value. The other column values alone need to be found out. So we need to find out the other two columns value, and then we need to find whether there is any change in the cluster numbers. So we need to find out these values. When we find out these values, we get these values again, or these are the cluster numbers. Now in this case, there is no change in the cluster numbers. Even though values are changed, there is no change with the cluster number. So with the previous iteration, with the fourth iteration and to this fifth iteration, there is no change with the cluster number. So in this scenario, we can stop. And we have grouped two data points, 2, 4 as well as 2, 6 to cluster 1. Then 5, 6, 5, 7, 6, 6 and then 5, 7 to cluster 3. The remaining data points to cluster 2. So this is k-means clustering. Thank you.